Welcome to the Slop Farm. Enjoy the video.
You start by preparing inputs and choosing the model. Gather labeled images with corresponding masks. Aim for balanced classes and at least 100 examples per class. Select an architecture such as UNet or mask RCNN based on accuracy versus speed needs. Once done, normalize pixel ranges and resize to a consistent 256 x 256 or your target size. This ensures stable training. You should also split data into train/val/test and create augmentation pipelines to expand variability before moving on. Now you train and refine mask predictions. Configure a loss that matches your goal, dice for overlap, BCE for pixel-wise accuracy, or a combined loss. Monitor EOU and mean average precision while training. Apply augmentations like rotation, flip, color jitter, and scaling between 0, 8, and 1. 2. To improve generalization. Use a learning rate schedule, batch sizes of 8 to 32 depending on memory, and validate each epoch so you catch overfitting early. Once stable, iterate with more data or model tweaks to improve output. Finish by post-processing and validating outputs for deployment. Threshold predicted probabilities, apply morphological operations or a CRF to clean edges and remove tiny artifacts. This yields usable masks for downstream tasks. If results remain noisy, ensemble multiple models or use test time augmentation to boost robustness. Make sure to inspect failures. Check class imbalance, mislabeled annotations, or overfitting from small d. If things go wrong, retrain with corrected labels or stronger regularization and reevaluate. This fixes most persistent issues.
Thanks for watching. Consider subscribing if we helped you today.